Hi, welcome to Algebra 2 Common Core. Today we're going to learn about a distribution of scores called a normal distribution. You may have heard of this before as a bell curve, but we're going to examine the percentages of scores within a certain number of standard deviations of the mean. So the normal distribution is centered on the mean. It's a symmetrical distribution with its center at the mean. So you can see below a picture of the normal distribution curve, again otherwise known as the bell curve. Where it says 0, that's where I would see the mean on my data. So the 0 is going to be the mean. All of the numbers to the right and to the left of the mean on the x-axis would be the number of standard deviations. So for example, if I'm looking at this number 1, it would be the score that's one standard deviation above the mean. If I'm looking at this number 2, it's 2 standard deviations above the mean. Each of these sections represent the percentage of scores that would fall within the number of standard deviations above or below the mean. The negatives mean that I'm going 1 standard deviation below the mean, or in this case 2 standard deviations below the mean. So we can predict how many scores will be in a certain range of scores by knowing the mean and the standard deviation. We learned in our last lesson how to use our graphing calculator to, for any set of data, establish the mean and the standard deviation. When not specifically told which standard deviation to use, in Algebra 2 we assume that it's a population standard deviation. However, be careful because there will be some problems that say use the sample standard deviation. So let's go ahead and look at example number 1, where we're going to use this bell curve to find percentages. So in example number 1, it says, for a population that is normally distributed. As soon as I see those words normal distribution, that tells me that I can refer to my bell curve. We want to find the percentage of the population that lies within 1 standard deviation of the mean. So once again, the 0 spot is going to be where the mean is. 1 standard deviation below the mean would go right here. 1 standard deviation above the mean would go right here. So in order to solve this problem, we want to add together all of these percentages between those two vertical lines. So I'm going to go ahead and write down what those numbers are. I see that I'm using 15%, I'm using 19.1%, but then I see that on the right side of the mean I have exactly the same two numbers. So I can add those two together and multiply by 2 because of the symmetry of the normal distribution curve. So adding these together on my calculator, I get 68.2%. That's a number that we're going to see quite often. With a normal distribution, generally 68%, in this case exactly 68.2%, of the scores should fall within 1 standard deviation of the mean. When I look at part B, it says, how about within 2 standard deviations of the mean? So I'm going to go back here and look at 2 standard deviations. So this time I'm using a blue pen. So here's 2 standard deviations below. Here's 2 standard deviations above. So I want to add together all the percentages between those 2 blue vertical lines at 2 standard deviations below and 2 above. So looking at all of those numbers, I've got 4.4 plus 9.2 plus the 15 and 19.1 that I saw in the previous example. Again, because of symmetry, once I add those together, I'm going to multiply by 2. And I find out that within 2 standard deviations of the mean, I should end up with 95.4% of my data. In part C, it says, let's look for more than 3 standard deviations away from the mean. So looking carefully at this, I see that 3 standard deviations would be right here. And I want more than 3 standard deviations away from the mean, so I want to say 3 standard deviations away. The part that's more would be this percent right here, but make sure that you remember to go below the mean as well, so I've got to go over on this side and say let's add on that 0.1%. So for C, we're going to say 2 times 0.1, which is 0.2%. For the last part of this example, it says between 1 and 2 standard deviations. So I'm focusing on this section right here. But again, if I want to, oh, it says above the mean, so I want to make sure I'm only in this section right here. So we're going to use the two percentages, 9.2% plus 4.4%. And that's giving me an answer of 13.6%. So using this normal distribution curve, I can predict the percentage of scores that will fall within any amount of ranges of standard deviations from the mean. So for the next exercise, exercise number 2, we're going to specifically look at Arlington High School with 424 juniors. That information about how many juniors we have will come into play as I'm solving these problems. These juniors recently took the SAT exam. On the math portion of the exam, the mean score was 540. So as soon as I see the mean, that tells me I've got to put it right at the center of my normal distribution bell curve. So very often I'm going to have to draw a sketch of what this bell curve looks like, and for this whole lesson we're going to need those percentages in front of us. So you can just keep referring to that diagram that I gave you in the notes. Now it also says that we have a standard deviation of 80. So what that means is starting with my 540 right here at the mean, I want to add 80 to get to one standard deviation above the mean. So 540 plus 80, that's giving me 620. And 620 plus 80, that's giving me 700. So I'm going to have to label my standard deviations above and below the mean to be able to solve these problems. 540 minus 80 is of course giving me 460, and 460 minus 80 is giving me 380. If I have to go further to 3 standard deviations, I can always add those onto my diagram. So the first question says, what percent of the math scores fell between 500 and 660? So if I look carefully at this, 500 is going to be right here between 460 and 540. So that tells me that I'm actually going to be a half a standard deviation below the mean. Going up to 660, that's going to be right here, halfway between 620 and 700. So basically I'm looking on my normal distribution curve between negative 0.5 standard deviations and 1.5 standard deviations. So go ahead and look at the numbers that we're going to have to add together there. I see that there are 19.9% to the left and to the right of the mean, so I'm going to have to use that percentage twice. And then I'm going to keep going by adding on the 15 and adding on the 9.2 to get a total percentage of 62.4% that would fall between those two scores. So I'm going to have to be able to use these percentages when given a standard deviation bell curve. And in this lesson, you will be given that bell curve. Now in part B, it says how many scores. So notice that the question changes. We're not talking about the percentage anymore. We're talking about how many scores fell between 500 and 660. Well, we calculated the percentage to be 62.4%. So let's change that to a decimal, 0.624. And multiply by the number of juniors that we had, 424, and that's going to tell me when I do that multiplication and then round to the nearest whole number that 265 students had to fall between those two scores if I had a normal distribution. Let's look at part C. It says if Evan scored a 740 on her math exam, what percent of the students who took the exam did better than her? So go ahead and look at your table here on your graph, and we want to say, okay, 740, that's going to be half of a standard deviation above 700, so right about there. So when I look at my chart, that's 2.5 standard deviations above the mean. I want to know how many did better than Evan. So if I want to know better than Evan, I want to look to the right of 2.5 standard deviations above. So that's going to tell me that I have to add together 0.5 plus 0.1. So I know that that's giving me 0.6%. So not very many people are going to have scored better than Evan. How many students in part D? So this time I want to know a number of students. So I'm going to take my 0.6%, convert it over to a decimal, 0.006, and then I'll take that decimal 0.006 and multiply by the number of juniors, 424 juniors. And that's going to tell me, it comes out on my calculator to be 2.544. But again, I'm going to round to the nearest whole number of students. So out of that whole group, only 3 students did better than Evan. So because Evan was so many standard deviations above the mean, that's why very few students did better than Evan. Now as you flip the page in your notes, at the top of the page, I want you to fill in the definition for percentile. Very often when we're talking about scores, we want to know what percentile a student scores at. The percentile just means the percent of scores below a given score. So for example, if you're told that on a certain test you scored the 75th percentile, what that means is that you did better than 75% of the rest of the people that took the test. That's really good. If you scored at the 30th percentile, that would mean that you only did better than 30% of the people that took the test. So a percentile is the percent of scores below your score. So let's look at example number 3 next. Biologists are studying the weights of red king crabs in the Alaskan waters. They sampled 16 crabs and compiled their weights in pounds as shown below. So the first part of the question says, determine the mean and the sample standard deviation. So notice that this time they specify that we want to use, instead of the population standard deviation, we want to use the sample standard deviation. So on my calculator, I'm looking for the one that's written like this, SX. Do me a favor and stop the video for a few minutes, enter this data into your calculator, use one variable stats, and come back when you have found the mean and the sample standard deviation for this data. Make sure that you round your answer to the nearest tenths. So using the calculator, I found that the mean score for the weights of the crabs was 12.6. That would be measured, of course, in pounds. And the standard deviation, and again I'm looking at the sample standard deviation, so S sub x is equal to 1.5 pounds. Now in part B it says, why does this sample indicate that the population would be well modeled using a normal distribution? Well, in order for it to be modeled with a normal distribution, I want to make sure that the percentages that I'm seeing in my data roughly match up with the percentages that I saw on that bell curve. So one way to test that is to take a look at one standard deviation above and below the mean. So I'm going to take my mean and I'm going to add one sample standard deviation. So 12.6 plus 1.5 gives me 14.1. Then I'm going to take the mean and subtract. I should have written subtract there. Sorry about that. Change that to a subtraction. So that turns out to be a mean minus a sample standard deviation, and that's going to give me 12.6 minus 1.5, which is 11.1. Now, when I look at the scores that fall between that, I'm going to go ahead back to my list and say, okay, the ones that are between 11.1 and 14.1, I'm going to go ahead and underline each of them if they fall within that range, and then count up which ones did fall within that range. And I see that I've got, out of my whole list of 16, I have 11 out of the 16 that did fall within one standard deviation. If I calculate that percentage, that's 68.75%. Well, remember, when we were doing our normal distribution curve back on exercise number 1, falling within one standard deviation of the mean should be 68.2%. So I really am very, very close to the percentage that I should see for a normal distribution curve. So my explanation should be within one standard deviation of the mean, 68.75% of the scores fall, and this is very close to a normal distribution curve where 68.2% of the scores should fall. Let's look at Part C. In Part C it says, assuming your mean and standard deviation from Part A apply to a normally distributed population of crabs caught in Alaska, what percent will fall between 9.6 and 15.6? So for this one, I'm going to now use my bell curve and say, okay, I'm assuming a normal distribution. So I'm going to draw one of those bell curves and I'm going to put this information on. So find an empty spot in your notes there and let's draw this bell curve. So I'm going to look if I want 9.6 and 15.6. Here's 9.6, 2 standard deviations below the mean. Here's 15.6, 2 standard deviations above the mean. So if I add together all those percentages, again remember in example number 1 we did the percentage within 2 standard deviations of the mean in number 1B, and that turned out to be 95.4%. So we are saying that 95.4% of the crabs that we catch should be between 9.6 pounds and 15.6 pounds. In Part D, it says a fisherman must throw back any crab caught below 10.4 pounds. Approximately what percent will need to be thrown back if the weights are normally distributed? So when I look at this and I look for 10.4 pounds, that's going to be right here on my normal distribution. So that's going to be below 1.5 standard deviations below the mean. So I want to add together all the percentages that are smaller than that. So I'm going to go to the left and say that's going to include 4.4, 1.7, 0.5, and 0.1. So when I add all those together, it's giving me 6.7% of the crabs will need to be thrown back in because their weight is too small. Example number 4 is an example of calculating a percentile. So the heights of 16-year-old teenage boys are normally distributed. So again, that really important combination of words there. When I see normal distribution, I think bell curve. The mean score is 66, so I have created a diagram here with the 66 as the mean and a standard deviation of 3. Now I only went to the right and added 3 to get 69 at 1 standard deviation above and 72 as 2 standard deviations above. In this problem we know that Jabari is 72 inches tall, so I was looking at that magical number of 72. Which of the following is closest to his height's percentile rank? So if we look at that, I see that he is 2 standard deviations above the mean. So using your bell curve, add together all the numbers that go up to and including that 72%. So we are adding all the percents that go this direction, from 72 down all the way to the left. Now when I added all those together, I ended up with 97.7%. So his percentile means that he is taller than 97.7% of the other 16-year-old teenage boys. So the closest to his percentile rank would be he's in the 98th percentile. In example number 5, I want you to try to draw the bell curve and come back after you've got the mean and the standard deviation represented, and we're going to look at approximately where 11.1 ounces would be. So here you can see my sketch of the bell curve for the soda. I know that the mean is equal to 12, so that's right there in the middle, and I wanted to find where 11.1 was going to be, so that means I'm going to the left of the mean. Standard deviation is 0.6, so 1 standard deviation below would be 11.4 ounces, 2 standard deviations below would be 10.8. and I see that 11.1 is exactly halfway between those two. So that means that I need to have the scores or the percentages that are below 1.5 standard deviations below the mean. So when I added together all of those percentages, I actually only got 6.7%. But now I want to know how many cans fall in that range. So I'm going to say 0.067 is the decimal, multiplied by the 250 cans of soda. And that's telling me that there's going to be 16.75 cans of soda. And in my case, I'm going to round to the nearest can of soda, so that's going to be 17 cans of soda. Now in example number 5, I want you to practice, example number 6, I want you to practice by drawing a bell curve and see if you can get the percentages in each of those ranges. Come back after you have completed it and check with my answers. So here's the sketch of the bell curve that I drew for this set of data. The mean is 500, the standard deviation is 35, so I tend to draw my sketch with 2 standard deviations in each direction. So I got that approximately 34.1% of the data falls between 465 and 500. So I can see that that is definitely just 1 standard deviation below the mean. It's just this section right here. I'm adding together 19.1 and 15. Between 500 and 570, that's going 2 standard deviations above the mean. So when I added those together, I got 47.7. 431 is really close to 2 standard deviations below the mean, so I know that it's between 1 and 2 standard deviations from the mean. When I went from 535 to 570, I added those 2 percentages, and that gave me 13.6%. And 465 right here, 1 standard deviation below the mean, when I added together all those percents, I got 15.9%. So hopefully this practice with standard deviation and bell curve was helpful to you. Tomorrow we'll be doing some more work in class on calculating percentages and numbers of scores that fall within a certain range using the bell curve. Tomorrow our lesson will be to calculate when I don't know exactly an integer value of standard deviations above or below the curve. So we'll see how we can do it if we know that we're 1.2 standard deviations above or 0.57 standard deviations below. Have a great night, and we'll see you next time. Thanks for working with standard deviation curves. Bye-bye.